Hi everyone, it's my great honor to present our work here. Our work title is A Multimodal Language Learning System for Chinese Character Using Foundation Model. We are from Beijing Normal University, Jinan University, TAL Education Group, and the University of Hong Kong. Through 3,000 years of involvement, each Chinese character tends to have multiple definitions with original and derived meanings, which is challenging for non-native speakers or even young native speakers to understand and remember. Fortunately, the language and linguistics study found that images could be used as nonverbal mediators, which helps learners build efficient connections between the information and the concept in memory. Also, psychologist Alan Piville proposed the dual coding theory, which indicates the equal importance of verbal and visual information. Thus, we propose a multimodal language learning system for Chinese character with both text and image definitions. We utilize text-to-image generation method to provide the desired images directly from text definitions. Text-to-image generation is one type of AI generation methods, and the cutting-edge enabling technology is based on foundation model. The capability of foundation model covers language, vision, speech, reasoning, etc. Generally, foundation models are pre-trained on large-scale data and could be flexibly adapted to different downstream tasks through transfer learning, so as to achieve excellent performance. Especially, zero-shot transfer is a feasible way to adapt the model to downstream tasks without tuning parameters. With the help of prompt engineering, the foundation model could be fixed and the prompts are used to trigger the model. Conditioned on well-designed text prompt, the text-to-image generation foundation models could create desired and original images. Here is the framework and workflow of the system. It can be divided into 5 main functions for learners. Firstly, learners could input query Chinese character through user interface, and the system would search Xinhua dictionary's online library via requesting API. The response is basic text information of the character, including pinyin as phonetic symbol, radical partially indicating semantic meanings, structured representing the stroke composition method, and its multiple definitions. Each definition contains the description of the meaning and its sample words. Secondly, learners could choose each text definition to show its image definition. The image definition is directly generated from the text definition by means of foundation model ERNIE-VUG tool. ERNIE-VUG tool is a knowledge-enhanced large-scale Chinese text-to-image diffusion model with 24 billion parameters developed by Baidu. Based on the basic diffusion model, ERNIE-VUG tool integrates textual and visual knowledge into the training process to help model focus on important elements, such as critical semantics of text and salient regions of images. The performance of ERNIE-VUG tool is state-of-art on text-to-image generation task of zero-shot FID30K from MS COCO dataset. Thirdly, learners could also choose to generate more images. The newly generated image would show up to the user interface and ask learners to judge whether it is appropriate enough to add to the image list. At last, learners are encouraged to develop ideas towards the image definitions by voting like for the most suitable one. The number of likes would be counted and saved as a key feature of the generated image in the cloud database. The image definitions of the chosen text definition would be displayed on the user interface, ranked by the number of likes. We demonstrate the text-to-image generation performance with an example of Chinese character Yuan that has 3 definitions. Each definition is combined by the description of the meaning and its sample words. The translations of the 3 definitions of character Yuan are showing as the following. Since the text-to-image generation requires well-pre-trained foundation model and efficient computing resource for model inference, we take advantage of Baidu Ernie Vilk 2 API and build local server to preprocess text prompt and request the API. The construction of the text prompt is important to the text-to-image generation model, which generally requires 2 main parts, namely painting object and painting style. For the painting object, we investigate 2 categories of text prompts with help of characters definitions, which are description only and both description and sample words. Taking the definition 2 of character Yuan as an example, we request the 2 categories of text prompt separately. The result shows that both description and sample words as text prompt would provide more proper results. To be specific, the presentation of Figure 1 focuses on the non-critical word villa from the description, while Figure 2 gets well understanding of both park from sample words and public place for people to play around and entertain from the description. It may be because the description tends to be abstract, while the sample words could provide more specific hints. For the painting style part, in addition to the realistic style, we also explore various artistic styles like surrealism, conceptual art, impressionism, and different production styles like computer graphic style, illustrator style, and pixel style. Considering about the generation issues for various Chinese characters, we set realistic style for older image generation. But the system designers or even learners could also make their own choices if needed. Based on the text-to-image generation results of the foundation model, the system supports learners to collaboratively refine the image definitions. As shown here, the 4 image definitions of the second definition of character Yuan are equally important to learners, which demands a high cognitive load to understand them all. To improve the learner's understandings of character definitions, the system encourages learners to vote for the most suitable images based on their understandings, and add new images as candidates when none of the generated images are favored. Ideally, the image with the most votes would be displayed at the top of the list on the user interface, and would be considered as the most appropriate image definition to the text definition based on the collective knowledge. The voting and adding image processes require learners to review the text definition carefully and figure out the key semantic meaning of the AI-generated image. Comparing the similarity between the text and the image definitions in mind, learners could strengthen the comprehension of the character via verbal and visual channels before making the rational voting decision. When new learners searching the same character, the previous work would support them understanding the text definitions accompanied with most relevant images ranked by others' votes. Meanwhile, new learners could also be inspired to progressively making contribution to the system and work collectively to develop the community knowledge. Here's the user interface of the system. Learners could input the query Chinese character in the search box and click on the search button. The system would then return basic information with multiple text definitions of the query character. After that, learners could click on each text definition to show the corresponding image definitions, where the generated images are ranked by the number of likes voted by other learners. It requires learners to browse the generated images from the top ranked to the bottom, and make their own decision to vote for the appropriate images by clicking on the Sum Up button. When none of the generated images is suitable for the text definition, learners could choose to generate new images by clicking on the Generate My Image. It takes around 10 to 20 seconds to generate an image. Before adding to the list, a pop-up would ask for learners' confirmation, which expects the learner to review the text definition and make a deliberate decision for the image definition. In conclusion, we propose a multimodal language learning system for Chinese character with the help of text-to-image generation foundation model, ERNIE-VIC2. Based on the text-to-image generation results, learners could help to improve others' understandings of Chinese character definitions by voting and adding images to re-ranked images display order. Consequently, learners could benefit from the top-ranked images for each character's text definition and improve the cognition through both verbal and visual channel. In the future work, to estimate the effectiveness of the system, we plan to design and conduct experiments by inviting entry-level Chinese learners to evaluate their learning achievement and attitudes towards the generated images and the voting system. Especially, it is also worth to investigate the effectiveness of various style images and how they provide improvement in the learning process. Besides, considering about the quality of generated images, the trust of the voting system requires further supervisions to correct typical mistakes from beginning learners and avoid unfriendly attacks. Since foundation models are pre-trained on large-scale data by black-boxed method, it is also necessary to require interventions to avoid risks of algorithm biases and intellectual property issues. Additionally, more flexible functions could be added to the build system. For example, in addition to like button, dislike button could also be an option to express learners' opinions on the image. To deepen learners' understandings, it also welcomes learners to make text comments on the image and leave nicknames and avatar to improve community awareness. Furthermore, the multimodal language learning system could also be transferred to other languages learning, with the similar mechanisms of text-to-image generation and learners' collaboration. Additionally, foundation models for AI generation are also powerful on text-to-text generation, image-to-text generation, image modification, etc. It would be interesting to investigate more possibilities of interaction and integration with AI-generated content and learner-generated content. Thank you.